This is the title of my presentation. So I'm wondering if anybody knows what this acronym BETEX stands for. As you can see, BETEX is acronym for volatile organic compounds. B is actually benzene, T is for toluene, E is for ethylbenzene, and X is for this isomeric Xylenes. As you can see, they all have aromatic structure, and ethyl and methyl groups attached on different positions. They're all clear, colorless liquids. They're very flammable, and also they have solvent-like smell. So this part that they're volatiles, we will use this for measuring them in the biological samples. So let's see what actually this volatile means. It means that compound can quickly evaporate because it has very high vapor pressure and low boiling point. When we said low boiling point, we mean, according to this European directive, that compound has boiling point less or equal to 250 degrees Celsius at atmospheric pressure. There are many sources of BETEX. Maybe the main is that they occur naturally in crude oil. Also, they are present in vehicle exhaust, also in tobacco smoke. They are also a product of processing of petroleum products, and also sources production of consumer goods. You can see that you can find them in paints, thinners, rubber products, inks, cosmetics, pharmaceutics, but also they can be something like intermediate compounds in production, for example, food packaging. Here you can see the BETEX fate in the environment. Once when they are released to the environment, they can evaporate from the, for example, water or soil. They can dissolve in water. They also can attach to soil particles, and they can be degraded biologically by microorganisms if oxygen is present. Gordana and Yasmina told you about this benzene in the air. When benzene, actually all BETEX are present in the air, they can be washed up with the rain in the rivers and or seas, and also they are prone to photo degradation. So main part of BETEX goes down on the soil and also after that in the water. You should you should look at this gas tank and gas leak. And actually this gas leak and petroleum leak can be the main reason for BETEX pollution in the earth. Here I collected some data from several researches, and you can see that Toluene is the compound that is present in the higher level, and it is derived from air breathing and cigarette smoking. If you look at benzene, then you can see that the main source of benzene exposure is food, not maybe food, but actually drink that you, water that you drink every day. So all others, they are present in lower amounts. If we talk about exposure routes and health effects, the main exposure routes is inhalation because they are volatile, but also people can be exposed through the skin or ingestion. Skin absorption is maybe characteristic for occupational exposure. Ingestion, besides food, can be accidental. Due to their lipophilicity, all these compounds can very easily cross the blood-brain barrier, and because of that, that can cause headache and dizziness. Also, if they're ingested, they can cause nausea and vomiting, skin irritation, but this one is actually the main problem, because benzene and their metabolites can go to the bone marrow, cause bone marrow depression, and because of that, benzene is classified as a human carcinogenic. If we look at this scheme, you can see that actually benzene is not the compound that is responsible for cancerogenicity, but benzene metabolites. They are formed in liver using different enzymes. And after formation in liver, this very reactive species can go to the circulation, then can go then to bone marrow, and these metabolites can form ducts with biomolecules in bone marrow, which are very toxic. And also they can suppress incorporation of iron into red blood cells and causing anemia. Let's say something about legislation. I will not talk about air because Gordon and Yasmina told you everything about it. Let's see about legislation about drinking water. According to European law, maximum permissible level or value is set only for benzene because it's carcinogenic. For example, United States Environmental Protection Agency set up maximum contaminant level not only for benzene but for toluene, ethylbenzene, and Xylenes because they are neurotoxic. Here you can see that this level is much more lower for benzene than from other compounds because benzene is carcinogenic for humans. If we look at biomonitoring, for example, if you measure benzene in air or in water, then you can actually cover only one source exposure. So to summarize or to assess the total subject exposure, you have to measure them in biological samples. On that way, you can actually take into account also exposure from every route, but also fraction of absorption, distribution, metabolism, elimination. So BETEX can be measured in blood, also in urine. And in urine, you can also measure, this is not working, but BETEX metabolites you can also measure in urine. The main drawback is that BETEX in blood has very short half-life, so you can actually take the sample end of the workday, and this biomonitoring is what I didn't say is mainly for the occupational exposure, because there is also law like for water, for workers that are exposed to BETEX in different industrial settings. So sampling is at the end of the workday and in the middle of the week, because this BETEX has very short elimination time. The problem for measuring BETEX is urine, that they are present in urine in very small concentration, because only less than 0.1 of absorbed dose is, you can find that in urine. So you have to have actually very sensitive method. Better way is to measure BETEX in urine because they have longer half-life. Drawback is that they are mainly not specific, and preparation method for BETEX metabolites is time consuming and it is the way that all very high concentration of different interferences can be present in the extract that we have to analyze. Let's see how do we do that. It's actually the same way where you can do it for liquid samples like water, urine, and blood. The technique is head-space solid phase microextraction. It is known for over 30 years, and it is very convenient because it's solventless very fast. And this is the principle. You put the sample in this closed vial, then you expose this sample. This sample is heated or not, but these BETEX are very volatile, and then they go from liquid part to the headspace part, and BETEX from the headspace part are adsorbed and concentrated on the fused silica fiber, which is coated with a thin layer of selective coating. After that, this needle is put in the injector of gas chromatograph, and our BETEX are dissolved first in the GC cone when they are separate, and after that they go to the separated. They go to the MS detector where they are identified by the structure. We can use different extraction time, different temperature, different fiber, depends on the type of the compounds we have. So what do you think? Is it easier to actually extract BETEX from water or for example, blood? Alternative is what is also used is static headspace. You have actually the same principle, but instead of this solid phase, this fiber, you have something like injection, in which you pour in aliquot of this headspace above the sample. But the problem is that you do not concentrate the sample, so this method is less sensitive, and here you can see that using this method you can analyze BETEX in ppb range, and using this method with concentration of the sample you can analyze ppt range. Here you can see the results of the analysis, and these peaks are, this peak number 1 is benzene, this peak number 2 is toluene, this 3 is ethylbenzene, methane paraxylene, they actually are calculated together, and this is orthoxylene. And you can calculate the concentration according to the area of the peak. This is the sample on urine. The question is, do you have to monitor BETEX anytime? Maybe not, because this is our results from different water samples in Croatia. So take a look at this unit, it's nanogram per liter, and I said that these limits are in microgram per liters. Here you have different samples: river, seawater, tap water, thermal water, wells, and lakes. All these results amount are very small, generally less than 1 microgram per liter. But look at this sampling site close to the oil wells. It's much more higher concentration. So you can conclude that it's good to monitor these compounds near the oil wells, some petroleum wells or something like that. At the end, when to monitor BETEX? When you have obligation according to law, for example, for drinking water monitor program, And as I'll show you, in thermal and surface water that are close to the oil wells because of the potential ecological risks. Then in occupational exposure, when we conduct biomonitoring according to the recommendation of the occupational medicine specialist, if he actually says that there is a risk of occupational exposure. Then in the case of accidents, if there is a leach from gas oil storage tanks and landfills, different accidents in petroleum and chemical factories, and in this case you measure in air, in water, and also in biological samples, and of course in scientific research when assessing carcinogenic risks, you have to measure BETEX as confounding factor.